The penultimate part of this chapter involves trying to describe a function in terms of two things really, injectivity and surjectivity. Now, if they have one or the other, they can be described as injective only or surjective only. But if the function displays both, only then do we call it bijective. And there's a bit of a hint in the name anyway, with the prefix bi. Bi means two, okay? So I'm really going to just focus in on injective and surjective, and what do they mean, and how are they recognized in terms of a given function with its domain, and with its range, and with its codomain. So consider the following function. Now again, we know what a function is, okay? There are really two things we've got to remember about a function. First of all, in every function, all the domain values are used up, okay? Simple as that. And secondly, in any function, we have to remember the vertical line test. In other words, if I take a vertical line through a given graph, does the vertical line cut that graph once only along every point? If the answer is yes, it's a function. If the answer is no, it's not a function. Okay, we studied that before. So just to take a look at these here, all right, we've got function called h, a function called f, a function called g, and a function called p. And they all have a domain, they all have a codomain, and then they all have a different relationship between their domains and their codomains, okay? So they may produce a range that happens to have the same elements as the codomain, or they may produce a range that is a subset of the codomain. I hope all that language makes sense to you. So let's take a look at the first one. In the first one, here's what we notice. All the elements of my domain are used. So straight away, this is a function, okay? And what we notice is that only some of the elements of my codomain are used. So in a situation like this, the range is not the same as the codomain. Now, that only happens in what we call injective functions, okay? If the range and the codomain are different, well, then we've got a situation where it may be injective. However, in this case, we notice that we've got two input domain values giving us the same output. So therefore, it fails on what we call injectivity. So this is just an ordinary function. This is a function. And it doesn't have the description injective or surjective. Okay. Next one, what do we notice? Again, all the elements of A are used. Over here this time, again, only some. So now we've got a situation where the range is not equal to the codomain. And that's usually a very good sign that this may be injective. And it will be injective if there is an individual, I for injective, I for individual. If there's an individual relationship between every domain value and a unique, what we would say, range value. So if you take a look here, only some of the codomain is used, so the range is not the same as a codomain. That's a good sign of injectivity. The last test for injectivity is this. Do all the domain values have a unique range value? And the answer is yes, because this one here goes to the first of B, this one goes to the third, this one goes to the second, and this one goes to the fourth. So in this case, the range and codomain are not the same, and there is a unique relationship, or a one-to-one relationship between the elements in my domain and the elements in my range. Okay, so that is a test for injectivity, which is passed. So that is an injective function. Okay, over here, all the elements of the domain are used, but more importantly, all the elements of my codomain are used. So in a situation like this, where the range is the same as the codomain, well, then it is not injective. It must be surjective, or might be surjective, okay? But we need to just do a quick test. If the range and the codomain are the same, then it is surjective, or it may be surjective and injective, okay? So first of all of them are used. So your range and your codomain is the same. Now, notice, is there a unique relationship between each of these? And the answer is no, because element 1 and 3 from A are both linked to the second output of B. So even though the range and the codomain are the same, we end up getting a shared output in B. And if there is a shared output, what does that mean? That means that we're dealing with a surjective function. Now, the way I remember it is the word surjective begins with S and shared begins with S, okay? So if they're all used up in your codomain, in other words, if the range and the codomain are the same, and there's any elements of your range that are shared with two or more elements from your domain, then it is definitely a surjective function. And let's go to the last one. All the elements in my domain, all the elements in my range are used up. So again, my range is the same as my codomain. Now, in this case, is there any sharing going on? The answer is no. Every input from your domain A has a unique output in B, and the output happens to be the codomain. The range and the codomain are the same. In a situation like that, where all the elements of B are used up, and they are all uniquely attached back to a unique value of A, this one is both surjective, because all the elements in B are used up, but it's also injective because there is a one-to-one relationship. So this is what we call one-to-one and onto. I'll come back to that word again, onto. Onto just means that all the elements in B are used, okay? So all the elements in B are used, yes. Are they uniquely attached one-to-one with A? Yes. So therefore it is both what we would say surjective, because all the elements of B are used up, and injective, because all the relationship between the domain values and the range values are uniquely one-to-one. And that is a bijective function. T-I-V-E, because it satisfies both what we would say injectivity and surjectivity. So therefore it's a bijective function. But really all you're looking for is injectivity or surjectivity. If it's present, if both of them are present in the one function, well then it's a bijective function. Okay, let's clear that and let's go through what I've typed here. So is H a function, and why or why not? Now we go back here to H. Is H a function? Well, are all the elements of A used up? Yes. Do all the elements of A, are they all attached to an output in B? Yes. Is it a function? Yes, it is. Okay, very simple. Again, if you had values, you could plot them and see then by using the vertical line test, does the vertical line go through this graph always at just one point? And that would be a test for functionality. Okay, so it is a function, and the reason why it's a function is because all your domain values are linked to a range, which is a subset of your codomain. F is injective. Now let's say why it's injective again. Because all your elements in A are linked to some of your codomain. So in this case here, we notice that the codomain and the range are not the same. Now, that's normally a huge hint for surjectivity, okay? So in this one here, or sorry, for injectivity. For this one here, when we have the 5 elements in B, out of which only 4 are in the actual output range, well then that is a real test for injectivity. It's called a one-to-one, or I like to say it's a one-to-one with sum, okay? So it's all to sum, all your domain to sum of your codomain, meaning that you'll produce a different range to your codomain. Okay, next question. G is surjective. But why is G surjective? And the reason why G is surjective is because all the elements in B are used, okay? That's a great hint. Now, all the elements are used, so therefore it's either going to be surjective and bijective or just surjective only. And here's the hint. If all the elements are used up and there is no sharing, if it's directly one-to-one, it's bijective. Here, what do we notice? Here we notice that all the elements are used up, but there is sharing. Elements 1 and 3 of A share element 2 of B. So because they're sharing, this is a surjective only function. And lastly then, as it's going to say, that P is a bijective function. Why? Number 1, it demonstrates surjectivity because all the elements of B are used up, but it also demonstrates injectivity because it's a one-to-one relationship. So therefore, both of the characteristics of injectivity and surjectivity are present, meaning that P, the function P, is a bijective function. Okay, so we've got the vertical line test. We know this already. If you have a function like this, all right, and you take a horizontal, just take a ruler and run the ruler across vertically across your graph. If that ruler only ever cuts the graph once as it moves across it, well then it is definitely a function, okay? In a situation like this, where you take your ruler vertically and run it across the graph, you notice that there are times when it hits the graph twice. Now that is not a function. Okay, simple as that. So the vertical line test tests for functionality, meaning if you draw vertical lines, do they hit once or more than once? If they hit once only, forever, then it is definitely a function. But if there's any part of that graph that causes the vertical line to run through more than once, then it's not a function. Simple as that. What about the horizontal line test? Now I would say, look, keep the horizontal line test for what we would say injectivity, for a one-to-one experience. If you have a horizontal line this time and you run your horizontal line through your curve or your line or whatever graph you have, if it cuts it only once at all parts, then it's injective. Okay, now it may be bijective as well. That's what we've got to remember. So we've got to be careful with that. Is it going to be surjective? And that all comes down to whether all the values in your codomain are used up. But we'll deal about that in a few moments. So let's take this function here, x plus 3. Consider the function in the domain from -2 to 6. Is it an injective function? So in other words, we have to focus very carefully on the domain. We're only working from there, okay, to 6, to there. So we're working inside those two red lines. Now, if I want to test if it's an injective function, I'm going to take that blue horizontal line and I'm going to run it down over the graph. What do you notice? When I run that line down, the blue line only ever cuts that function once. So that is a one-to-one relationship. So that is guaranteed to be an injective function. Okay. Now, here's the more unusual thing. Is it bijective? So in other words, if I take my blue line and I run it up and down, now notice that here we're going to R. We're going to a codomain that takes in every number. So in other words, we're going the full length of the y-axis. If I take that blue line above 9, well then between those two red lines, it doesn't cut anymore. So therefore, what do we notice? We notice that it's one-to-one with only some of my y values, which means that it is injective only. It is not surjective. To be surjective, it would have to cut all the values of the y-axis between those two lines. Okay, so that would be injective only. Okay, there's the blue line. And you notice that as we move downwards, we'll just do that again. As we move downwards, let's go back and do that again. Oops. As we go, oh, sorry, geez, apologies. Let's go back and do that again. As we run the blue line downwards, notice it only cuts that line once between the two red lines. And that's important, okay? We're working between -2 and 6, that's key. And we're looking to see what does the blue line do between -2 and 6 as I move it up and down. The answer is that between here, there, and here is where the blue line will definitely cut the graph one-to-one. But above those red lines here and here, there's no relationship with the blue line of the function. So therefore it's not surjective, because there are y values that this blue line can't produce once it goes above the value of 9 and below that value down here, which is what, roughly about 1. Okay, so just be careful with that. So it's injective only. Okay, horizontal line test for surjectivity. Very simple. If injectivity is the horizontal line cutting a graph at most once, then surjectivity is a horizontal line that will cut the graph at least once. It may cut it more than once. Okay, so consider the function f, which takes, now that's your domain. Okay, so every number in your domain, but only between, only to the codomain of -1 and 1. So we're only working within -1 to 1 here on the y-axis. We're taking every x value, but only a height of +1 and a bottom of -1. And we're taking the domain and changing it into a range by using the sign of x. Okay, in the domain from 0 to 2 pi. Now, look, I don't think we've touched these before, but I'm just going to introduce them very, very quickly to you. 0 to 2 pi is a full revolution. Okay, it's another way to say 0 to 360 degrees. And we're dealing with sine and we're dealing with cosine. Now, normally, sine and cosines only ever run from +1 to -1. They don't ever go outside that. Okay, and the shape of the graph repeats itself every 360 degrees, which is 2 pi. So therefore, we've got 360, that's 180, that's 90, and that's 270. And here's what happens with sine. Sine starts there, peaks, goes back, drops, and goes like that. So you get a sine wave, which is like this. Okay, now what's the cosine? Cosine kind of does something similar. So cosine, again, only goes between +1 and -1. And again, let's just take up to 360, which is the same, 2 pi. And then you have your 180, you've got your 90, and you've got your 270. Now, for the cosine, we start here and we drop like this. So we get a graph that goes like this. Okay, that's the basic shape of the sine wave, and that's the basic shape of the cosine wave. All right, and they're two things that you do need to imprint on your head. So the sine wave starts at 0 up and down between 1 and minus 1, whereas the cos starts at 1, drops to minus 1, and goes back to 1 again. Now, what are we asked to do? We're asked to use the sine of x. Okay, so I'm not going to bother with this one over here. I'm going to take this graph, and we're asked to test it between 0 and 2 pi. Now, be very careful. My domain is between 0 and 2 pi. So make sure there's 0. So between there and there's 2 pi and there. So we're only looking between those two goalposts. Test the function for surjectivity. Okay, bring in your horizontal line and run your horizontal line down. What are we told? Between minus 1 and plus 1. So the horizontal line is only allowed to work between there and there. Now what do you notice? If I run the horizontal line between these two, it's going to cut the graph more than once. That's guaranteed surjective function. Okay, it's a guaranteed surjective function. Okay, so there's the graph as I told you already. Now, the domain is between 0 and 2 pi. So your domain is only working from there to 2 pi here. So you only mark off what you're dealing with, what you're working with. And also, what do we notice? That you're working in your codomain between minus 1 and 1. So we're only working between here and here. So what it does is it compartmentalizes your graph into just that window, and you're only focusing as what's happening between those four lines, the two over here on the sides and the one at the top, one at the bottom. So when we move this blue line, you can see very, very clearly that there will be cases where it cuts the graph more than once. If you bring it up to the top, it'll cut it twice. Sorry, cut it once. If you bring it down to the middle, it'll cut it twice. And if you bring it down to the bottom again, it'll cut it once. Okay, so if we go from here down to here, now this is where you've got to be careful, because once you get the blue line down here, it's going to cut it in two places. Yeah, and then if you bring it further down again, it'll be two places there and there. So it is cutting the graph more than once, which means it is a surjective function. So since the horizontal line cuts the graph at least once in the given codomain, the graph is surjective. Okay, so here's an example. Consider the function f, which takes your domain from 0 to 2 pi and takes your codomain of all real numbers by taking your x values and turning them into the range of the sine of x. Okay, so let's consider that. What does it ask? Is the function injective or surjective? Now here's what I'm going to do. We're only working between 0 and 2 pi. So 0 and 2 pi on the x-axis. Okay. We're also using all the codomains. We're using everything here, from infinity down to minus infinity. Okay. Now, what does that mean? Well, 1 minus 1. What does my sign look like between 1 and minus 1? Well, there's 1 and minus 1. Here's what it does. 180 is halfway, 90 and 270. So the sign, what's the sign do? It starts at 0, goes to 1, back to 0, down to minus 1, and back again. So I get a graph like this. Now, apologies for me drawing this, but I'm using the screen like this. Okay, so there's my graph. Now, is the function surjective? Well, don't forget, my codomain is running from infinity to minus infinity. So the first thing I've got to remember is it injective? If it's injective, then the horizontal line will only cut the graph once. Okay, let's run down between minus infinity and plus infinity. There are stages where the horizontal line doesn't cut the graph at all. Okay, and then there are stages where it cuts more. So it's definitely not injective. Now, is it surjective? And in order to be surjective, the horizontal line has to be able to cut the graph more than once at every value on the y-axis. See that? Every value on the y-axis. So therefore, if I run my horizontal line from infinity all the way down to 1, it doesn't cut it at all. And as soon as it hits 1, it's going to hit it once, then it'll hit it twice, and then it'll hit it once at the end again. So is it surjective? It's neither. Okay, so in that case, we reject both of them. It's not injective because it's not one-to-one, and it's not surjective because not all the values of my codomain are used. I've got all these values here that are not used, they're not used, and all these values here that are not used. So therefore the answer is neither happens to be the case. It's not injective or surjective, it's just a function. Okay, a general function as we call it. Okay, let's get rid of all that. Take that off. And let's go through what's typed. So there's your function, as we said already. From 1 to -1, starting up here, and 2 pi. It's a full revolution. Now, because of the fact that my codomain is r, I'm also going from infinity to -infinity. But the horizontal line only has an impact on the graph between 1 and -1, which means all these values are left out in your codomain. All those values are left out. So therefore, there's only a connection between your domain and some of your codomain, and that's not what surjective means. So in that case, what do we notice? The horizontal line test fails for injectivity, and it's not surjective either because it says not all the values of the codomain are mapped. So it fails both tests. So if it fails both tests, what is it? It's just a regular function. It's not described as being injective. It's not described as being surjective. It's just a regular function. Okay, and that's what you need to keep in mind. Okay, so what does bijectivity mean? Bijectivity means that all the values in your domain are linked to all the values in your codomain. Okay, now that link of all the values, that makes it surjective in your codomain. If the relationship between all the values in your domain and all the values in your codomain is uniquely one-to-one, well then it's also showing injectivity. So therefore, if it's injective by a one-to-one relationship between domain values and range values, and if the range is the same as your codomain, meaning all the values in your codomain are used up, then it's guaranteed to be bijective. So when you're looking for a bijective function, you're looking for the presence of injectivity and surjectivity. Okay, so bijective functions are both injective and surjective, meaning both one-to-one relationships and all the values in the codomain are outputs. So they're the key things to look for. So you're looking for here injectivity, and if all the values of the codomain, that happens to be surjectivity. Whoops, so easy. Try and go back there. That's surjectivity. Okay, and if both of those are present, then yes, it's bijective. Okay, let's take a look. Is the function f, which takes every value in your domain, every real value I should say, and maps it onto every real value of your codomain by taking your domain values and transforming them into the range of values of 4x plus 2, is it a bijection? Now, think about that. We're using every value on the x-axis, every value on the y-axis, and we're plugging in the x values to see, do we get a unique y value for every value on x? So in other words, we're going to be using something like this. So we're going to be moving from infinity to -infinity, from infinity to -infinity. That's what we mean by or, okay? Or in the domain, -infinity to infinity. Or in the codomain, infinity to -infinity. Because don't forget they're the x and the y axis, okay? Now, what's the function? 4x plus 2. So let's take 0. At 0, if I put x equals 0 in, I'll get y equals 2. Okay. If I take 1, I'll get 6. And straight away I've got a line. Okay. You only need 2 points to plot a line anyway. So I join them together, like so. And I continue forever. And what do I discover? I discover, through the horizontal line test, that between infinity and -infinity on the y-axis, every one of the values on the y-axis is linked uniquely to a value on the x-axis. So thanks to the horizontal line test, is there injectivity? Yes. Is there one-to-one? Yes. And the last thing to check is all my codomain used? And the answer is yes. So if there's a one-to-one between your x's and your y's, and all the codomain values are used, both injectivity and surjectivity are present, meaning yes, it's a bijective function. Okay, so again, you graph it, and we've done that already. There's your graph. Then you use the horizontal line test. So will that horizontal line test cut that graph only once at every value between infinity and minus infinity on the y-axis? The answer is yes. So therefore, straight away it's 1 to 1. And because all the values in the codomain are covered, it is most definitely a surjective function. So it's 1 to 1 and onto, which means yes, it is most definitely a bijection. Okay. So to summarize, if I wanted to remember this thing quite quickly, the differences between them, what would I say? Well, first of all, here's what I would say. In every type, whether it's injective or surjective or both, all the domain values are used. And that's key. Because in order to be a function in the first place, all the domain values have to be used. Okay. Secondly, it's only the injective type of function that does not spit out a range that is equal to your codomain. Range and codomain will be different for an injective function. Okay. Are all the range values unique? In other words, is there a 1-to-1 between the domain and the range? Yes. So how would I recognize an injective function? Simple. If some of the elements that are present in your codomain are not in your range, if your range and codomain are different, chances are it's injective. Just test for 1-to-oneness between the ones that are actually given to you. What about surjective? Again, all the elements in your domain are used. All the elements of your codomain is used, but there are elements in the codomain that could be shared between 2 or more values in your domain. So we're looking for surjectivity. We're looking for presence of sharing. Okay, that's the key thing. And then for bijective functions, we notice that again, all the elements in the domain and all the elements in the codomain are used. But in this case, every value in your domain is linked uniquely to every value in your codomain, which means it's both injective 1-to-1 and it's mapped onto, meaning it's surjective also. Therefore, it will show both, giving you your bijective function. So maybe that table might just be a little easier for people to understand when we're dealing with injectivity, surjectivity, and bijectivity. So surjectivity means all the values in your codomain are used. Okay. Now, if they're uniquely linked back to A, to the first group, to your domain, then you have a bijective function. But if they're sharing, if you have values in your codomain that are shared outputs between 2 or more values in your domain, well then you still have all the elements used up, but because there is sharing involved and it's not uniquely 1-to-1, it would be surjective, surjective only. Okay, so if there's sharing involved, it's surjective but not bijective. So it's clear to see that only in the injective function do we have a range that is different to a codomain, where the range is not the same as the codomain. If the range is equal to the codomain, and there are shared outputs. So in other words, if you had something like this, just very quickly show what I mean by shared output. Let's say we had let's say we had A, B, and let's say we had C and D. Put D in here and E in here. Okay, so say we had the following. A is mapped to C, B is mapped to C, D is mapped to E. What do you notice? Are all the elements of my codomain used up? Yes. So therefore, it could be surjective. Let's check. Are they uniquely linked? No, there's a sharing. C is shared between A and B. So although this shows that it has all the elements of your codomain used up, your codomain values are shared with some of your domain values, meaning it is surjective only. Okay. And finally, if the range is the same as the codomain and there are unique outputs. Now, what do I mean by that? Well, let's take it very simple. A, B, C, D, E, F. A to B, C to E, B to F. Now, first of all, are all the elements in your codomain used up? Yes. Surjectivity. Are they uniquely linked back to the domain? F is to B, E is to C, D is to A. Yes. So there's 1-to-oneness as well. So because they're all used up and there's 1-to-oneness, that would be a bijective function. Okay, so let's take a look at these. I'm going to go through these with you very quickly and see, can we throw these into the category of being injective, surjective, or not? Okay, so down here, state whether the following functions are surjective or not. So we want to look for the ones that are surjective first of all. What does surjective mean? Surjective means all the elements of your codomain are used. See, it's the simplest way to do it. Surjective, all the elements of the codomain are used. So, are they all used up? Yes. All used up? Yes. All used up? No. 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 Yes. No. Yes. Yes. Done. Now, let's just go back and see if we can further explain what they are. Here, is this bijective as well? Well, it's surjective, but because the second element of B is shared between the second and third of A, it's not injective as well. So it's surjective only. See that? Okay, next one. Here we notice, yes, it's surjective. They're all used up. And again, we notice that the third element of B is shared between the second and fourth of A. So again, it's only surjective. Next one, not surjective. Why? Because you've got an element here in B that's not used up. So therefore, if all the elements not used up, it's not surjective. So how could I describe it? Well, between the remaining elements, there's a one-to-one relationship with A. So this is injective. Okay, what about part 4? Again, it's not surjective because there's an element in your codomain left out. So your range is 1, 2, 4, and 5. 1, 2, 4, and 5. 3 is not used up. So your codomain and range are not the same. So in this case, it's injective because again, there's a one-to-one relationship. So that's an injective function. So between all the elements in B that are used up, they're uniquely traceable back to A. That's fine. Next one. Is this one bijective? Let's check. No, it's not even surjective, okay? Because again, there's an element left out. So is there a one-to-one relationship with all the rest? Yeah, this is injective. What about this one? Surjective, they're all used up, but all the elements in B are uniquely linked to all the elements in A. So here's a bijective function because not only is it surjective, it is injective as well. It's onto, every one of these is mapped onto A, and it's also one-to-one. This one here, again, we can see there's an element of B not used up, so it is injective, because it's one-to-one. This one here, all of them are used up, and are they unique? Well, that's unique, yeah. That one there, yeah, they're all unique. So in this case, you also have a bijective function, because one-to-one and all used up. And lastly then, now there's a little bit of an interesting twist on this thing. We only looked at B, yeah, surjective, right, they're all used up. But hold on a second. Can one person be in 3 different places at one time? The answer is no. So therefore, in essence, really at the end of the day, now the question doesn't ask us this, but at the end of the day, this is not a function at all. For the simple reason that you can't have A in 3 places at one time. You can't have one person in 3 different cities. So therefore, doesn't appear to be even a function. But look, for the moment, the question just said, are they surjective or not? So you just check the codomain. If all the elements in the codomain are used up, it is surjective. Okay, next example. Page 160, question 13. Describe the following functions as injective only, surjective only, bijective, or none of the above. Okay, so let's take the first one. What do we notice? Our domain runs between 0 and infinity. So therefore, in the x-axis, we're only dealing with there to there, okay? On the y-axis, our codomain, we're only dealing from here to here. So in other words, we're only dealing with this quadrant, just this quadrant, okay? And because it's only that quadrant, we have to look in to see, is the horizontal line test going to tell me injective or surjective? Now, let's move the horizontal line test upwards along this. If I put a horizontal line anywhere there, once, there, once, there, once, what does that mean? We have a one-to-one relationship in here between all the codomain values and the domain values. Meaning what? Meaning that this one happens to be bijective. It's bijective because there's a one-to-one relationship, and secondly, every element in Y is going to be used up. So that one there is bijective. Okay, next one. What do we notice? We're using on the x-axis everything from infinity, minus infinity to infinity, and we're also using on the y-axis everything from infinity to minus infinity. So I'm going to do my horizontal line test. If I do my horizontal line test here, 1, 2, 3, cuts it more than once. It is surjective if all the elements in Y are used up. And the answer is yes, they are. So this is a surjective function. And finally, if we're working between pi and 2 pi on the x-axis, so in other words, pi and 2 pi. So we're only working between those 2 red lines, okay? However, we are using everything on the y-axis from infinity to minus infinity. Now straight away we can see if I put the horizontal line here, it cuts nothing. So we only have a one-to-one relationship with some of my domain values. And that means then that this is injective only. Because when the horizontal line does cut the graph, it cuts it only once. But when the horizontal line is pushed above the graph, it doesn't cut anything. So therefore, only some of the values on the y-axis will involve cutting the graph, one-to-one, others won't. So that's an injective function. So that's the quickest way for me to describe those to you. Okay, last one. Page 162, question 26. Consider the function f running between your domain of minus pi over 2 and pi over 2 and your range minus 1 and 1. Okay, so we're doing the sine of x. Now, sine of x, as we know, goes from 1 to minus 1. And it runs out, as we're told, only as far as pi over 2. Now, that's 2 pi, that's 360, okay? That's pi there, and that's pi over 2. So in other words, we're only working in here, between those two red lines. We're only working between minus pi over 2, so that's back here, minus pi over 2, and pi over 2. Now, what does a sine function look like? A sine function, as we know already, peaks at pi, down here, pi over 2 I should say, down here, then for this one 270 down to here and here. So we get a graph like this. That's the sine graph, okay? Which means that it's going to be down here like that, okay? Down for the minus 1, down here. So we're working between these two. And again, you've got to be very careful that you know your boundaries. So your boundaries on the x-axis are minus pi over 2 and pi over 2, okay? What are my boundaries on the y-axis? Minus 1 and plus 1. Okay, so there's my boundaries. Now, I'm focusing in here, all right? Is it a bijection? In other words, are all the y values covered between minus 1 and 1? Yes. And as I move the horizontal line between minus 1 and 1, what happens? It cuts the graph once. Draw a horizontal line there, cuts it once. Here, cuts it once. So as I move between 1 and minus 1, all the elements in there are used up, and there's a one-to-one relationship. So it's onto, and it's one-to-one, which means, yes, it is a bijection. Okay. Now, over to you. See if you can understand all that terminology that's involved there. You'll see that there are page 160, 161, 162, 163, those various questions. But I want you to look at the online questions first. I think these online questions are much nicer for you to get a grip on what it means to be injective only, surjective only, or bijective. Okay? I want you to take a look at them and just make sure that you understand exactly what the functions mean in terms of being able to map the points, but also in terms of the functions themselves. So do the online questions first, and when you've mastered those, then go on to the textbook questions from page 160 to 163. The one thing I will say to lead us into the next section is that the bijective functions, bijectivity meaning that they're both one-to-one and onto for all the values of your codomain, they are the only functions that are invertible. They're the only ones that have an inverse. Okay, so moving forward, we will only be moving forward with bijective functions to look and see how do I develop an inverse function in relation to those.